When you talk about aircraft and aircraft performance, you can divide aircraft into two different types. One that has utility value and one that doesn't have any utility value. Power planes, for the most part, almost all have utility value. They can exist to do a lot of different things for a lot of different people. Gliders, on the other hand, have utility value for certain specific areas and not for a lot of other areas. You can't go from point A to point B in a glider and make sure you're going to get there. You can't necessarily say, I want to climb up to 10,000 feet. There might be not enough lift that day to get you that high. So when we talk about aircraft, we talk about utility value. Now, the fact is that there are benefits from having a power plane and benefits from having a glider. And let's go to those individually. Power has much utility value. Gliders have no significant utility value except in certain specific areas. And we're going to look at those. In terms of performance, power planes have a lot of performance in a lot of areas. They have research and development, carrying passengers, crop dusting, highway patrol, pipeline patrol, medevac. The list goes on and on. In terms of performance, a power plane can give that kind of performance because you can control altitude. With regard to engine design, if it's a power plane, it can be used to examine and do research on different methods of power. It could be piston, diesel, rotary, turbine, jet, and even electric. Hopefully, before all of you complete your program here at Greeley College, you will have the experience of being able to ride in or fly an electric airplane. Greeley City owns 2 electric airplanes. They are currently being stored over at Fresno Chandler, but at some point in time they're supposed to be delivered over here to Greeley Airport. In terms of commercial applications, that is commerce, business, getting the best utility value from a power plane, there are a whole wide range of applications that have value if you have a power plane. I used to have a sign on the back of my car that said, "Fly a glider just for the fun of it." And that's mostly true, but you're going to see a particular application later on in this presentation about the Perlan project. That's the aircraft that went to 76,100 feet. We'll have some video of that aircraft, of that glider. When we say electronics in the multiple applications, does anybody think of an application where the aircraft would be loaded with electronics? Daniel? Airplane parts, yeah, that's one. A cargo. How about operating electronics? How about a Hurricane Hunter? Have you ever seen the inside of a Hurricane Hunter plane? 4-engine? It's crammed with electronics because it's full of experts and research people that are trying to understand. They fly right through the hurricane, right through the wall of the hurricane, through the eye, back into the hurricane, and back through the thunderstorms. And the plane is literally packed with so much instrumentation that they really don't have enough room to carry people just for the heck of going through a hurricane. So that's one of the applications where power has some significant value. Speed characteristics in power. Right away you're going to think to yourself, well, gliders can't do much in the way of speed. And the answer is yes, they cannot. They cannot at all. We want to go fast. We have to give up something. What is it? Yeah, in the form of what kind of energy? Potential, yeah. So a glider doesn't have any choice. If you want to go fast, you have to give it up. If you want to go slow, you can actually get altitude. So you're always trading back and forth. Whereas a power plane, they have that little throttle, right? And that throttle just gives you altitude or no altitude. So you have all kinds of options with power, but that you don't have in gliders. And one of the characteristics of speed is they were able to understand what went on beyond the sound barrier. By the way, speaking of sound barrier, I asked the question on the test, who were the two pilots on board Voyager? Did everybody get that right or wrong? Pardon? Wait a minute, hold on. Martine, go ahead. What was the answer? It was false. Because I had Chuck Yeager there instead of Gina Yeager. And so if you didn't read it carefully enough and you just said, oh, Yeager and Rutan, yeah, that's the answer. No, they're not. So beyond the sound, you can certainly do it with a high-performance aircraft. You can't do it with a glider. Pardon? There was nothing on board. Remember how tight the cockpit was? They couldn't stand up. They had to crawl back and forth in the fuselage. Okay, the SR-71, we're going to see a couple of videos on the SR-71, which are really fun to watch. They're not very long, 5 or 7 minutes, something like that. But let's go see what they look like here.
Leading a Ryder Cup team requires an understanding of what's at stake.
Don't forget, there's some material here for notes. Okay, this one's a little bit longer and has a little bit more information in it.
Pratt & Whitney J58 engines, big enough to power the Queen Mary, launch its 140,000-pound body to the edge of space. The bullet from a high-powered rifle leaves the barrel at about 3,000 feet per second. On a routine mission, the Blackbird travels faster, 3,200 feet per second, for up to 90 minutes at a time. No matter how serene it may look, this kind of speed requires unyielding precision.
You know, Mach 3, boom. The turn radius is something like 100 miles, and they have all these critical fuel problems and other stuff. And so it's not a very spontaneous experience. These are carefully planned, choreographed missions.
With the thunderous clap of a sonic boom, the Blackbird hurtles through the frigid atmosphere, leaving a fiery tail of shock diamonds in its wake. At 2,200 miles per hour, the aircraft becomes superheated from the friction created as the air rushes by.
And indicating Mach 3.0 at this time.
When you go Mach 3, the amount of heat that the whole airframe, everything experiences all this heat, and nothing that they have at the store works. You know, there's no paint, no rubber, nothing. You know, metals, plastics, all this stuff is useless. And they just had to go through so many contortions to make every single part of the plane tolerant of these extreme temperatures.
Temperature affects everything on this airplane. The average person probably is not cognizant of that fact, but the faster you go, the harder things get.
The Lockheed jet is 9/10 titanium, and when they build it, the CIA uses a phantom company to buy the material from the world's largest supplier, the Soviet Union. In flight, the titanium skin reaches 1,000 degrees Fahrenheit, causing it to expand by more than half a foot. This heat-induced expansion posed a real challenge to the Skunk Works team.
When in design they found that the aircraft was heated and then cooled, then the titanium skin would buckle and not return to shape. They found by longitudinally corrugating the wing and fuselage parts of the aircraft, then the aircraft could go through the heating cycle, cool back down, and return to shape.
One of the puzzles of extreme heat was never really solved.
Sealants for the fuel tanks. They never came up with a polymer that would seal the joints in the skin panels that hold the fuel in. So the Blackbirds sit on the ground and weep. That seems silly. You can look, oh, these stupid guys back in the 60s didn't know what they were doing. There's still no plastic, you know, that can get to 700F and not turn into burnt hot dog oxide.
Once at altitude, the heated skin stretches, sealing the aircraft's fuel cells. In its 30 years of service, only 150 aviators have qualified to fly the SR. It is an elite fraternity. Prior to every Blackbird mission, 36 hours are devoted to prepare men and machine for flight. One of the most valued traits is maturity. Lieutenant Colonel Mike Finan is 43. All who enter the program must meet one fundamental requirement. They must be married.
Lean forward, sir.
Most importantly, they must be physically fit. At altitude, even a simple toothache can lead to blackouts.
12115. Coming down, sir.
The two-man crew is essential to success. Soon, Pilot and Reconnaissance Systems Officer, or RSO, will be traveling faster than a speeding bullet while operating some of the most sophisticated intelligence apparatus ever built. They are, in effect, the Blackbird's central nervous system. 2 brains, 2 pairs of eyes, 2 sets of hands. Without them, this mass of metal and electronics could not function.
Something that's different about flying the SR-71 is the absolute and total man-machine integration. People talk about strapping an airplane on, but I don't believe you strapped an airplane on until you've snapped your spurs into the ejection seat, and you hooked up your life support hoses, and you've been given that responsibility.
Before flight, each of the SR's huge power plants requires a jump start from two 454 cubic inch Chevy engines. The whine is deafening, and the steaming tarmac reeks of JP-7 seeping from the plane's unsealed fuel tanks. So much fuel is lost prior to launch that the Blackbird takes off with nearly dry tanks. The SR must join with a waiting tanker just minutes into flight. Slowing this trisonic jet to match the tanker's subsonic speed is anything but easy.
It is a very difficult task for the pilots. That is one of the things that washed people out of the program more than any other part of the regime.
United 382 Salt Lake, 330.
You always breathe a sigh of relief when you feel the boom kick you off and you know that you're full and you can go again.
15 minutes and 80,000 pounds of fuel later, the Blackbird is ready to retrieve images from halfway around the Earth.
Telephone 15, back to the 70, looking for left turn heading 223.
I hope everybody got a lot of that information written down. I know some of you are just sitting there enjoying the film. Others were writing judiciously, so they're probably going to get a little bit better grade on the quiz than others. So we'll talk about gliders now, because gliders really operate in a very different realm of flight. There are different applications for gliders. In fact, gliders can do things that most powered aircraft cannot do. Right now, the Blackbird went to what altitude? 85,000 feet, right. And the latest glider altitude record was 76,000, right. So the glider is gaining on the Blackbird in terms of maximum altitude. But my guess is that if the Blackbird really wanted to set up an altitude record, instead of going around the world as they did, they would just put that nose up in the air and turn on the rockets and go. So it's likely that the glider altitude record is not going to be a standalone all by itself for all aircraft. It's going to be for gliders only and for a lot of other ones. Commercial airliners cannot possibly go that high. Why not? Well, in a way, that's the right answer. But just think about, pardon? No, that's not good enough. Osvaldo? Well, at that altitude, what's the problem? Lack of air, right? I mean, you need a lot of air, tons and tons of air to burn in a jet engine. And the higher you go, the thinner the air. And it's going to get to the point where no matter what kind of power you have in that jet engine, it's not going to do anything. You're not going to be able to go anywhere. So, not a single commercial airliner would ever get as high as a glider, ever. I mean, it would be a waste of time to build a commercial airliner for that particular one. All right, so gliders can be used to do a lot of weather and aerodynamic research. And they can do weather because the weather will affect the glider in many different ways. When you take a power plane up in the air, the propeller of a power plane masks what's really happening aerodynamically to that glider or to that power plane. It's only when you remove the propeller and get rid of the engine do you now feel the true air currents and what they're doing and what they're not doing. So only by getting rid of an engine and a propeller can you get a better feeling for weather phenomena. And we talked about that before. Remember, we talked about the mountain wave as being one of the most fearsome lift sources in existence. And it was discovered by gliders and research done by gliders into mountain wave. They can also do high altitude research. What's wrong with the SR-71 doing high altitude research? Yeah, it's going too fast. Exactly. Way too fast. Too heavy, too fast. It's got too much engine propulsion. It just goes and tears right through airwaves. So if you had a mountain wave and you had ripples downwind from a mountain range, SR-71 would feel that. They might bounce a little bit. It might feel a little bit of a shudder as it went through those airwaves, but they would have no idea what they just went through. I mean, at 2,200 miles an hour. So let's take a look a little bit here at the glider realm. By the way, I will point out to you one of the pictures of all the men in the project that were standing here looking at the camera. The man on the far right is a very, very close friend of mine. He's also a glider pilot out at Avenal. He also is the guy that gives glider check rides for your license. His family used to own a crop dusting business in Chowchilla, and he himself is a weatherman, and he was the weatherman for that entire project down in Argentina. Great guy, great guy. Extremely knowledgeable. This looks like it's a pretty short one.
Our goal is to fly to incredible altitudes in the stratosphere.
We need very special conditions to fly into the stratosphere. Yes, this glider does actually do what we designed it to do.
The dream was born for Paralon Mission 2. A lot of individual.
Anybody know where that camera was mounted? No, it was mounted up on the tail. Most cameras, if you're going to record things like that, are mounted up on the tail, looking forward down the fuselage and to the wings. Okay? So just be aware of what you're seeing from the entire Perlan project. It was mounted on the tail. You could probably see the hole right there right there. Can you see that in the back? The camera? Okay. That gives you an idea of what we're seeing.
Has got involved to make that dream a reality.
We've come to El Calafate in Argentina.
Our goal is to get into some rising air.
We're looking for areas of lift that will enable this aircraft to get into the upper reaches of the atmosphere.
And there's only a few places on Earth that have stratospheric waves.
We can put the glider into a patch of air that is going up at incredible speed, 1,000 feet per minute. You know, the same kind of speed you're climbing when you're in an Airbus airliner. We're going up at that speed, and it's actually nice to fly.
The virtual cockpit gives us all the information on the ground that we need to know if the flight is progressing safely and smoothly, and that we're able to continue to progress higher and higher.
We've added even more to the virtual cockpit. So this year we have a live video feed from the tail camera, which should immerse the user even more into the flight experience of Perlan.
We look at the pressure in the cockpit, in the capsule. We look at oxygen that the pilots are breathing. We're looking at the battery. We're looking at temperatures at various instruments.
If you want to be an innovative company, you have to be doing things that nobody else is doing, trying things nobody else is trying, and doing them in a way nobody has done them before.
Perlan is an amazing opportunity that you don't get very often.
We worked with a small school that's trying to form hypotheses and get kids inspired in science, technology.
Aviation is a fantastic potential career.
There is true adventure, true exploring here.
The perspectives you get from flying high, the freedom, the enjoyment have just been fantastic.
You can actually get on when they're flying. You can get on, and there's streaming directly from the cockpit right to the internet. By the way, you saw this thing inside the Airbus. Airbus put a lot of money into the Perlan project, and so they're going to reap some benefits from it later on. Okay, we have one more video to take a look at here. I think this is the one where right off the bat, the men were standing there. They took a day off and they went to one of the towns nearby, and pretty soon you'll see, there he is on the far right, in the striped shirt. He'll come. His name is Dan Gudgel, and Dan is a great pilot. This is the area of Argentina that they did all the flying in the Perlan project. We talked before, you had to have a mountain range. You get up and over the mountain and then rip to the other side. Those are South American condors. Very, very similar. I think they actually used some of the genetics from the California condor to help save the North American condor. I don't think I'm going to look at this very long. It's just, but when you're in a glider, with the exception of the music you hear, when you're in a glider, it's exactly that. It's completely quiet. It's smooth. It's just like you're in a different world. Now this is coming in for a landing. You see on the wings right there? Those are dive brakes. And if you didn't have them, it would probably take you 3 full days to get down from that altitude, because it's such a slow descent. So you have to have something that kills the lift in order to get the glider to come down faster. So all the way down, they've got to use those dive brakes. Matthew? Oh, flaps you can use to increase your lift and then decrease it depending on the position of the flap. These, once they come up, you're just killing the lift. That's all it is. Pretty soon you'll see down below the airport that they're going to land at. So while we're watching that, the point is that there are 2 very significant differences between no-engine gliders and power planes in terms of their application, in terms of what you can do with them or without them. So one of the quiz is going to focus on the major differences between power aircraft and gliders and the applications that each one of them on their own can perform better than the other. I want you to understand the difference between them. Almost looks like a simulator or a video, doesn't it? I mean, a video game. one of the really strong benefits of a glider over a power plane is wing design. Does that wing design below, the bottom one, does that remind you of any kind of wing that you've run into before in one of my lectures? Which one? Pardon? Boeing what? How about the new one? The one that's made out of mostly 50% composites. The one that bends way up, right? The 787. That's exactly right. Take a look at the 787 wing, and it would very much be similar to the wing of that glider in the bottom of the picture. So wing design and aspect ratio is very, very important, because the longer the wings and the thinner the chord, remember the chord line? That was a question on the test, wasn't it? The angle between the angle of attack and the relative wind is called the chord. Okay? So, flight characteristics and energy transfer. And there's another quick YouTube. This is what I like to do once in a while when I'm flying my glider. So I get a kick out of it. I'll show it to you. This is one of those things we talked about before, where you can transfer energy between kinetic and potential, right? See the stuff trailing behind the glider? That's water. It's used as ballast sometimes, and in order to, you can't land with water in your wings. You've got to get rid of it before you land. They're probably doing about 140 miles an hour, which means that they've built up enough kinetic energy so when it comes time to land, they pull up and they transfer kinetic energy to potential. And then they get into the pattern and land. And the noisier the glider when it comes screaming by means it is less aerodynamic. So if you have a glider that comes by and it's relatively silent at 140 or 120 miles an hour, see, now that one's pretty noisy. I happen to know what kind that is. It's a Grove 103. It's a two-place glider, but it's got a lot of parasite drag to it. So it makes a lot of noise when it comes screaming over the airport. The glider I have hardly makes any noise at all. So there's a big transfer, right? From kinetic energy to potential energy. It's a perfect example of an aircraft swapping energy levels in flight.
One day, one afternoon, no motor. Here comes Dougie now for a high-speed pass.
I find this incredible that he's not actually landing.
He's got the confidence to come down the runway at that height, knowing that he hasn't got an engine.
Hear how quiet that one was?
Well, that's energy management, ladies and gentlemen.
But you see how long the wings are, how long and thin. Why aren't the wings bending on this one? Because he's not pulling any G's, right? He's not pulling up. As soon as he starts pulling up, the wings bend up. He didn't pull up fast enough, so you didn't get a chance to see it, but anybody notice on the Perland glider whether it was retractable gear or fixed gear? Pardon? was a fixed gear on the Perlan. I knew you'd all appreciate that. You have a lot of water in those wings. You put water, that's where you put the water in the wings. That looks like the same model glider I have. Okay. We have a couple of animals in the room. I hear strange noises coming from someplace in the room. I just wondered if we had some animals that made their way in here. Gliders set the progress of composite materials, mostly by the Germans, because they build the most high-performance gliders. The best gliders in the world are built in Germany. And they started using composite materials long before anybody else did. In fact, Bert Rutan learned a lot about doing composite materials from the Germans. In addition to that, we have on board glider computers. They're pretty sophisticated. They measure, among other things, they measure the thermal you're in, the speed of the thermal, the updraft velocity. They measure how well you're doing in that thermal, and they also measure the entire air mass that you're flying in. And an air mass could be 5 miles square. But air masses are moving, aren't they? And you're flying in that air mass. So a glider computer can measure all three of those things independently. Okay, that's it for today. Tomorrow, I hope you get the test back tomorrow. And we'll go over them briefly. But the information on the test today will not be on the final exam. Final exam will only cover the 6 quizzes and the 6 lectures preceding the final exam. October 12th is the final exam. Jacob? I can't hear you. What?
Can I get your signature right here for the activity on Friday?
That's for what now?
I'm going an activity for choir and myself.
Yeah, you probably are going to need my signature.
So 5th period right there. 5. Thank you.
Remember, your essays are due on Wednesday. I know it's a little late to be asking questions about the essay, but you can do that by emailing me. remember we made a deal that when I'm talking, you don't? I want you all to succeed in business or in industry or wherever you're going to be. So some of the stuff that might be a little tough to learn in this class are going to benefit you. I don't want you to learn anything that's not going to benefit you in the future. It has to do with talking while somebody else is talking. It has to do with moving around when everybody else is sitting there sort of paying attention. These are the kind of things that are tough to learn in a different environment. You don't want to learn in an environment where somebody will say, if you can't behave yourself, you're fired, get out of here, right? You don't want to learn in that environment. You want to learn in my environment, where all I can do is maybe yell at you or caution you a little bit to kind of get your act together. When you leave here, the last time you see me, I want you to walk away feeling like you gained something significant out of being in this class. Right? By that I mean you can take anything you want with you, whatever it is, whether it's academic, whether it's behavioral, whether it's intellect, whatever it is. You should be able to walk away from this class feeling like you've accomplished something instead of just coming here to get away from your high school in the afternoon. I realize that's an incentive, too, get away from your high school. But still, there's a lot to be learned in this college atmosphere that I think will be beneficial for you. We've got a couple minutes before you can go, so any other questions about anything, about the test? So there were no questions on the test that you didn't already know about once you decided to turn in your paper? Sergio, how about you? Maybe you may be the only honest guy in the room at this point. I can't imagine you failed. I don't think everybody else failed either. I think you all did pretty well. Well, there were some questions there that were pretty obvious. One of the questions that I thought might be a little tricky is when I asked the question about what did Emirates Airlines do to hedge their bet. I gave you three choices, and then the fourth choice was B and C. And if you had chosen B and C, that would have been wrong because they did not cancel all of their remaining orders for the 380. They continued to accept delivery. The only thing that we ever defined was that they bought 150 Boeing 777s. So you actually thought maybe that they canceled all the other 380 orders? No, we never talked about them canceling. In fact, you may remember if they were willing to take all of the off the production line because all the other airlines canceled theirs. But had to agree to taking all the necessary production. They didn't. They accepted what they ordered, but they sure didn't. Okay, everybody. See you tomorrow at 1 o'clock, 1:20. On a glider ride? Yeah. Yeah, you betcha.